this slide shows the vector addresses of all vectored interrupts of the 8085. So we obviously are interested in the hardware interrupts, and for the hardware interrupts over here the vector addresses are shown. So these are the fixed addresses fixed by the manufacturer. These addresses are the addresses where your program is going to jump to as soon as the interrupt is going to occur. On this side, this table shows some of the software interrupts. So instead of writing a call, you are actually going to write RST0, and if you do that, then your interrupt subroutine or your overall execution is going to jump to 0000, where the interrupt subroutine corresponding to RST0 would have been written. In general, for this course we are not looking at software based interrupts because they are nothing but a relabeled version of call subroutine. Now there is something important to be noticed. For example, the address location of the interrupt subroutine for RST 6.5 is 0034 in hex. Similarly, the interrupt subroutine address for RST 7.5 is 003C. So which means how many bytes or how many words or instructions can you write between these two address locations inside your instruction memory? For example, if I subtract 3C minus 34 in hex, you are going to get only 8 bytes or 8 words. So within 8 bytes you are not going to be able to write a long interrupt subroutine, because in general your subroutines or an interrupt subroutine is going to perform hundreds of assembly language instructions. So within 8 bytes I will not be able to write more than 3 or 4 instructions, which means how am I going to actually write a large instruction subroutine? So obviously the answer to this is that when you jump to this particular location, okay, the first thing that you write here is another jump to another location, which means that I would be writing jump to another label at which particular location? 34. So if I have to write a large interrupt subroutine for my RST 6.5, then the first instruction as part of my subroutine that I will write at 0034 would be jump to some other place, and at that other place I can write a very large interrupt subroutine consisting of very large number of assembly language instructions. So now in general, please note that the instruction memory addresses, indirectly the vector addresses, are already occupied by these interrupts, and up till what point? Up till 003C, which means that addresses roughly up till 0040 are already occupied as the vector addresses of your various interrupts, which means my main program should always be written after 003C, or if I keep some buffer after 003C, then I am saying that we should write our main program in the 8085 starting at 004F, giving some amount of buffer after 003C.